There are two main types of probabilities, experimental and theoretical. A theoretical probability is what we expect to happen based on assumptions that we're making. So an example would be that we assume a coin is fair and that it will land an equal number of times on heads and tails. So that's how we come to say that it's got a 1 in 2 chance of landing on heads. Experimental probability is based on what actually happens after an experiment or something like a survey. A coin is flipped 10 times, and 8 times it lands on heads. What is the theoretical and experimental probability of getting heads on the next flip? Well, the theoretical is just the number of outcomes that are heads, which is 1, and the total possible outcomes, which is 2, heads or tails. So that's 0.5 as a decimal times by 100 is 50%. So that's our theoretical probability of flipping heads. The experimental probability. Well, in that case, we flip the coin 10 times, 10 total times, and in 8 of those times, we got heads. So this time, 8 divided by 10 is 0.8 times by 100 is 80%. So the theoretical probability of flipping a coin on heads was 50%, but after flipping it 10 times, on 8 of those times we got heads, so 80% is that experimental probability. Now, which is better? I mean, in this case, it's definitely theoretical. In this case. And that's the important part. Flipping a coin 10 times isn't that many times. You know, you can have a streak where you flip 6 heads in a row, and then, if you're only flipping 10 times, that's going to throw off the probability. So, 10 samples probably isn't that much, isn't that significant. If you were to flip a coin 1,000 times and find that 80% of the times it landed on heads, then there'd be an issue. Then maybe we can start to trust the experimental probability more than the theoretical probability. So let's look at an example where you might draw some kind of probabilities from a survey. So a rec center surveys members about what activities they prefer. They're asked if they would prefer spin class, aerobics, rock climbing, or weightlifting. What's the probability that a member will select rock climbing? Well, let's look at how many options they have to choose. 1, 2, 3, 4. So theoretically, if they have 4 options, we might say that the probability is 1 over 4. That's one option is rock climbing, and they have 4 options to choose from. That's 0.25 or 25%. So now the rec center gives out the survey, and they find that 245 of their members say that of the 560 that submitted responses would prefer climbing. So what's the probability that a random member would choose climbing? Well, that would be 245 divided by 560, which is equal to 0.4375. Or, as a percentage, 43.8%. So why are those two probabilities different? Why is the theoretical probability and this experimental probability different? Well, it's because when we made that theoretical calculation, 1 in 4, we assumed that all the choices were equally likely to be selected. But really, there's no reason to assume that. In fact, we would expect that one or two of these activities are going to be way more popular than some of the other ones. So in this case, what's better, the theoretical probability or the experimental probability? I would say that this experimental probability is better. Because really, the assumption that we made doesn't really have a lot of reasoning behind it. So the experimental probability is the actual feeling that the rec members have.